Hi, hello everyone. Welcome to TerraSpatial. In this video tutorial, we are going to see how to delineate watershed using QGIS. So let us get started. The first step will be we are going to add our raster layer. Add raster layer. So use this option to browse for your file. So you can see here this is my DEM file, DEM digital elevation model, and this is the SRTM DEM. Each pixel's resolution is 30 meters. So if you haven't downloaded any DEM data before, I have already made some videos for downloading the DEM datasets from various sources. So I'll be sharing this link in the description. You can just check it out. So now let us move on to the QGIS. So after adding the DEM data, so basically what is DEM data? DEM data, it contains elevation of a terrain. So each pixel should be having an value that is nothing but the elevation value. You can see here the highest value is 1903 and the lowest is 69. This represents the height of this region. You can see here 1903 is the highest elevated region in this selected area, and the lowest is 69, and the units is in meters. So if you just pay a close look at this raster data, which is representing the elevation, you can see the white color. So the white color represents the highest elevated region, and you can also find black color. Black color represents the lowest elevation region, and you can see in between, you can see the image is turning from white to black, and the in between elevation is being represented in this color. So this color scheme has only two colors in it. If you have more colors, you can easily identify how the elevation of the terrain is. So now let us go to the properties and find about the raster data, what it is made of. So right click and go on to properties. Here in the information section, you can find the details about the raster data. For example, the name, where it is located, size of the file. You can check the extent of the image. If you come down, you can see the pixel size. So the SRTM DEM which I am using is 30 meter in resolution, but you can see the pixel size here is somewhere in 0.002. Likewise, so this is in decimal degrees, not in meters. That is why the value is like this. If it is projected, it will be coming in meters, so it will be coming around 30 meters. And if you just check on the coordinate reference system, now it is currently in geographic coordinate system, which is less accurate for performing a spatial or hydrological analysis. So the next step is we are going to reproject the raster to projected coordinate system. Now it is in geographic coordinate system. We are going to project it to projected coordinate system. So select raster, and here you can find projections, and you can find warp here, warp reproject. So this is a tool using projected coordinate system, because in projected coordinate system the units of measurement is in meters or in feet. So that is more reliable, high accuracy compared to the geographic coordinate system. So geographic coordinate system uses the decimal degree as units, so which is not very comfortable for making any measurements, and geographic coordinate system suits a global level data set. On the other hand, the projected coordinate system can be used locally or regionally with a high accuracy, and offers the spatial analysis accuracy with a very high, and distance and area calculation is very much accurate in projected coordinate system. So you can just have a look at this table. So I'll be also sharing this in the description section. You can just have a look at it. So now let us reproject. First is the input layer, that is our DEM dataset, and next is, you can see the source CRS. So the source CRS for this dataset is geographic coordinate system, as you can see here, EPSG 4326 WGS 84. So we are going to select that one. You can see here. Now you can see the target CRS, so we are going to choose the projected coordinate system. So for me it is already available, so let me show you how to select it. If you just click on here, you can choose predefined CRS, and from here you can type in and find out the projected coordinate system which suits your area of interest or your region. So in this case I am going to use UTM zone 43 and N means northern hemisphere. So I'm going to select it. So once I have selected, you can see at the below, you can see the region. You can easily identify the region over here, right? So in order to find it for your region, it is simple. Open a browser and you can see, you can just type in world UTM zones, just search for it. You'll be getting some image like this. If you don't find it, just come down. You can see a link over here, www.dmap.co.uk. I'll be also sharing this link in the description. From here you can also find the projected coordinate system zones for your area of interest. So in this example, let us take Madagascar as an example, and you can see here for this region you can check in the zone, that is 38, and if you just move on to the left hand side, you can find S. It is starting from here. S is nothing but the southern hemisphere, N is nothing but the northern hemisphere. So if your region falls in the southern hemisphere, we have to choose what? 38. Our UTM zone will be 38 and it is coming under southern hemisphere, so we are going to select S. This is just for an example. Now let us move back to QGIS. So once you have selected the coordinate reference system, just move back, just check it. Okay, right, you can see there the chosen coordinate reference system, and just come down. Here we are going to save the file to a particular region. So here you can find Reproject. Click on here. Two options will be available: save it to temporary file and save it to a particular location in your drive. So click on to save to file, and I am going to save it to a particular folder, and I am going to rename it as DEM Reproject. Save it and click on run to begin the process. So now you can see the process has been completed, and you can also find some difference in the elevation. This might be due to it is being converted from decimal to meters, so there might be some difference in the elevation. As you can see here, some difference in the elevation has been seen. So now if you just right click and go on to the properties, come down, now you can find the pixel size in meters. So you can see here the pixel size is around 30.26 meters. And if you just come down to the coordinate reference system, you can see now it has been reprojected to projected coordinate system. Okay, now you can see in projects, move on to properties. Here once again select the projected coordinate system which we have chosen for the DEM dataset. Same, we have to select it. If you don't find it here, you can just directly type in over here. Just type in UTM, type in your zone number and which hemisphere, right? So I'm going to choose this one. Once you have chosen it, in the down bottom you can see it, visualize it. Click on apply and click OK, right? So we have reprojected the DEM dataset. Let us remove the old DEM data. So the next step will be to clip this raster layer, just for an example. So if you are if you know where is your study area falling, it is well and good. If you don't know, it is not a big thing. So you can see here, this is the Basemap plugin, HCMGIS plugin. I'm going to use this, and I'm going to add a Basemap Google Satellite Hybrid. Once I have added it, let us bring this DEM layer to the top, and you can easily find out your area of interest by simply For example, my area of interest fall over here, and you can see some regions names or location names is available. With that you can easily find out. So this is my area of interest. So if you want to clip it, you can clip it, because most of the DEM data will be covering a larger area. So if you just clip the DEM data, it will reduce the processing time and power. So in order to clip it, go on to raster. So under that you can find extraction. So you can see two options are available. One is clip raster by extent, and one is clip raster by mask. So if you use this clip raster by mask, you can use your shapefile and you can clip it easily. If you have any shapefile, you can first you need to import the DEM dataset, and after that we need to select our shapefile. Once you have done it, you can just put on the source. It's just optional, but make sure that the DEM data and your shapefile are in same coordinate reference system. That will be correct. So just make that show both are in same projected system or coordinate reference system. So you can just click on here and save it to the particular file. So in case you don't have any shapefile, but you know where your study area falls in, there's another option. Once again, raster. Here you can use clip raster by extent. So you can choose first we need to choose the DEM data, and after that we are going to calculate it. You can use any raster layers, you can just use that to calculate the extent. Otherwise you can simply draw on map canvas. For example, in this case my area of its interest is here, this much area only. So I'm going to just draw a box like this. Right after drawing the box, you can see the clipping extent has been automatically selected. Now what we have to do is simply we are going to save the file. So in this case, this just an for example I'm showing you. I'll be saving to a temporary file. You just need to click run. So once it is done, you can see here, let me remove the previous DEM data. Now it has been clipped successfully. Like this you can clip your raster layer. So I have shown you just as an example. So now let us quickly begin with the process. So please make sure that you have enabled this processing toolbox. It will be available here. Now we are going to use the field tool. So at the top you can find the search option. Here you can search for the tools. So under the SAGA next generation tool, you can find the fill tool. So you can see here fill, sinks, Wang and Liu. So open this tool. So what this tool does, so you'll be downloading the DEM dataset, right? So in the DEM dataset there might be some depressions and peaks. For example, you can see some sudden drop in the elevation in the DEM dataset, or you can see a sudden peak in your DEM dataset. These can be both naturally and processing errors or sensor errors. In order to rectify those depressions and peaks, we are going to use this tool called as fill sinks. So you can also find more about this tool. I'll be sharing these links. So you can see here sinks and within brackets peaks are often errors due to the resolution of the data or rounding of the elevation to the nearest integer value. Sinks should be filled to ensure a proper delineation of basins and streams. If the sinks are not filled, a derived drainage network may be discontinuous. So you can just have a look at the sinks or depressions in the DEM datasets. You can see the elevation profile over here, and you can see a sudden drop or depression or a sink over here, you can see. So in order to maintain the flow or the slope of the elevation, you can see this is being filled up like this to remove the depressions. This remove the discontinuous in the drainage networks. And if you see the next, you can see the peak. So in this elevation slope, you can see a sudden rise. This is called as peak. So using this tool, we can also remove the peaks. So the naturally sinks can occur due to a crater or lakes, and in case of data processing, this can be occurred due to the lesser resolution of DEM datasets or processing error. Sometimes it can also occur due to the sensor malfunctions. So same, you can see in case of peak, this can be some ridges or mountains. So you can see some peaks due to that naturally, and it can be due to the low resolution DEM datasets or processing errors, both in capturing and ground station processing. So now let us move on and let us use this fill tool to remove the sinks and peaks in our dataset. So you can see here some other outputs is also available, and you can see flow directions, watershed basin. So we don't require the flow directions and the watershed basin. We just need to get the DEM to be filled. So here, save it to a particular location, or you can save it as a temporary file also. So I'm going to rename it as DEM fill. Now let us hit save and click on run. So you can see here the processing has been done. Let us close it, and you can see some difference in the elevation. You can just compare it, the filled and unfilled dataset. You can see some increase in the lower elevation value from 76 to 77. I think some sinks might be removed, that's why there is a difference in the elevation from 76 to 77. Now let us remove the previous DEM dataset. We are going to now use only the DEM fill. I am also removing the Basemap. So the next tool is stream order, that is Strahler's stream order. At the top you can search for it. So Strahler's order, you can find it in the terrain analysis channel. Under that you can find Strahler order. Open this tool and our elevation dataset will be DEM filled, and let us save it to a particular location. Save to file. So I'm going to name it as SO, that is Strahler's order. So before running this tool, let us see what is this tool is and how it functions. There are different methods to calculate the stream order. In this case, we are going to use the Strahler stream order. Why we are using this? Because it is simple and easy to calculate in GIS tools like ArcGIS and QGIS. It effectively shows the hierarchy and connectivity of the river system, which provides a good correlation with the stream size and channel characteristics. Now you can see here Strahler stream order classifies the hierarchy of the streams and rivers in a river system from the smallest to biggest. You can see from the smallest tributaries to the largest one. So basically how this stream order works. So you can see here, based on the Strahler stream order, it classifies the hierarchy of the streams or river. Okay, right? So you can see the first order stream, which has been indicated in the blue color, and it is also called as headwater streams with no tributaries. You can see here first order stream, individuals. You can see that it doesn't have any tributaries like the second order stream where two streams are joining together. No tributaries are there. These are called as the first order stream, and when this first order stream transforms to the second order stream, so in this case you can see here two first order streams join together to form a second order stream that is being indicated in green color, right? Likewise, when two second order streams joins together, it makes the third order stream. So you can see here the green color is a second order stream from here. From here also you can see a green color second order stream. When these two joins together, it makes the third order stream, that is in orange color. Likewise, two third order streams joins together to make a fourth order stream. For example, you can see here there is a third order stream, here there is a third order stream. When these two joins together, it makes the fourth order stream. And you can also see if a lower order stream joins a higher order, the stream retains the higher order only. Like this, you can see here, this lower order stream is joining with the higher order stream called as 4. But still it may retains the fourth order. It won't change because of this single stream. You can see the same example over here. Now let us come down. You can see another illustration of the stream order. So what can the Strahler stream order tell us about the river system? By knowing this order of the stream, we can better understand our rivers and how to best protect and manage them. So if you take the first order streams originate from rainfall, snow melts or springs. They are usually found in more hilly areas and move quickly downhills, and they do have a good erosive in nature. While the first order streams might move quickly, the overall volume of the water is very low because it is a very small stream, so the water will be low in the first order stream. Many do not flow continuously throughout the year and may only have a water after a rainfall or during snow melt. So when you are just concentrating on the higher order streams have a wider channel, deeper water and move slower because you can see they carry a large volume of water because they receive the input from many tributaries. For example, you can see here, this is the main order stream. So you can see a lot of tributaries from the first order and second orders come and join here, making the water larger in volume. So you can also see the importance of the higher order streams. It provides the habitats for more biodiversity because of their large size, slower moving flow. They can support a diverse range of plants and animals. By identifying a river order, we can better protect its unique ecosystem. These higher order rivers are more prone to floodings. Understanding the stream order can help in predict where the flood might happen, and we can plan accordingly to prevent the floods. And stream orders can be used to monitor water quality issues. Pollution in smaller or first order streams can eventually flow into the larger river. By knowing a stream order, we can track and control the source of pollution to protect the quality of the downstream. So I hope that you have understand what is the stream order. Now let us run the process after inputting the elevation data, and we have saved it to a particular location, the output. Let us click on run. So you can see here the process has been completed, and you can see the result file. You can see a lot of streams, and you can see some higher order streams also available here. Many streams are there, so we don't need this much of streams information, so we are going to reduce it. So this is solely based on our purpose. At what level we require the stream, we can choose it. So you can just check in the stream order. It is available from 1 to 10. So I am going to just fix it to a particular stream order because we are having a vast amount of streams. So now let us reduce the stream order. We can do that by using the raster calculator. Go on to raster and from there use the raster calculator. So in this case I am going to use the raster called as SO stream order, which we are Strahler's order. So double click, automatically it will be added to the raster calculator expression, and here please use greater or equal to, and I am going to set the threshold of 6th order. so I'm going to use 6. You can choose it accordingly. Now once after giving the expression, you can use this option to browse and save your file. So for this I'm going to just name it as raster calculator. Now hit on save, click on OK to begin the process, and you can see within a fraction of time we have got the result, and this is the raster calculator file. Now let us classify it. Go on to properties, and here you can see symbology. In the render type, please choose unique values, and after that just click on classify. You can see two values will be appearing, 0 and 1. So one is the streams, so I'm going to just double click and going to choose a color for it. Okay, after choosing the color, click on OK. Apply, click OK. So now you can see the darker streams, which is in blue color, which is the area of interest for us. If you want, you can also remove the transparency, change the transparency. So I'm going to set it to 0 opacity. Apply, OK. I think now you can have a better view of this, right? So in the next step, we are going to convert this streams. Now it is in raster. We are going to convert it to a vector. So once again, move on to this search bar, and this time search for channel network and drainage basin. So once you have put in the channel network, you can find the tool called as channel network and drainage basins. Open this tool. So now we are going to input our elevation dataset, that is DEM fill, and here the threshold value is 6. It should be matching with the raster calculator where we have set the threshold to 6. Now after that, you can see some other files will be also generated with that, so we don't require that files. So first I'm going to remove the junctions, drainage basins, right? Once again, drainage basins, stream order, flow connectivity, flow direction, sub basins. So now let us run the file. Before that, we are going to choose the output location for this channel. So use this option to save it to a file. This time it will be saved as a shapefile. So let us name it as channel and click on save, and let us run the process. Now after clicking run, you can see the process has been going on. It will be taking some time, maybe a minute or so, based on your DEM area coverage. So the process has been completed. You can just check in. The orange color has been coming up. So now let us click on here, double click, and we are going to change the symbology for it. So I'm going to just use this one, every line, and I'm going to choose a color for it. So after choosing color, click on apply, click OK. Now you can see here the result file, how it looks like. Now let us see how to delineate watershed. So we are going to use a tool called as Upslope area. Just type in Upslope area. So you can find it in the terrain analysis tool. Just open the tool. This is how the tool looks like. You can see the target area, that is optional, and the important thing is we are going to give the target X coordinate and target Y coordinate. So what is this target X and Y coordinate? So if you take this example from here, you can see that I have already told you that this is my area of interest. You can see the boundary clearly, like this one. So for this entire watershed, this much of area, you can see the outlet. So for this entire watershed, the outlet is over here. So this is the outlet from where the water is joining to the others. So I am going to just use this, or I am going to just use a point and define the outlet, and with that we are going to input the x and y value. So after inputting the x and y value, you can see a watershed will be created. Let us see how to do that. So you can see layers, and you can see create layers, create a new shapefile layer. So let us first save it to any particular location, and I'm going to save it in the common result file. I'm going to name it outlet. So this is the outlet of that watershed. Geometric type will be point, and the projection will be same as we have already set the raster projection, that is UTM zone 43. We should not change it, right? After that we are going to create some fields. I'm going to create a field as x and use decimal double as the type. Now after doing it, I can click on add. It will be added over here, and followed it by y, same decimal double. So two fields we have created in order to extract the x and y value of this point. So now click on OK. Now after that, select the point and just start toggle editing, and we are going to create a or add point feature. So for this entire watershed, this is the only outlet, right? So I'm going to just make a point layer at the top, and let me just, for example, I am just giving the ID as 1. Once after doing it, now we are going to extract the x and y values for this point, so that we can create a watershed for this area. So now open the attribute table, and here in order to find the x and y value, just move on to the option open field calculator. Now you can see here create a new field. So we are going to update the existing field. First I am going to select x, and in the search bar I am going to just type in $and x. $and x, it will be there in geometry. You can see after double clicking it will be automatically added to the expression, and you can also check the preview value. Click on apply. You can see we have found the x value, and let us find the y value. So now choose the y field, and let us remove this $x. Now let us search for $y. Same in geometry it will be available, $y. You can check the preview, apply OK, save your progress. Now just open the upslope area, and here what we are going to do is, first we are going to copy the x value, and we are going to paste it here, and followed it by the y value. Select copy and paste it in the y value. Now in the elevation you can use the DEM fill. Sinks roots is not required, it's just an optional. So in this case I am going to use the deterministic 8 method. Deterministic 8 approach is a common method used in hydrological modeling to calculate the flow direction and upslope area from a digital elevation model. So how it works, it calculates the flow direction by assigning each cell's flow to one of its 8 neighbors, that is the one which is has the steepest descent. From this it can compute the upslope contributing area. So in simple terms, the deterministic approach is, imagine a water drops falling on a hill. Each drops flows to the neighboring cells that has the lowest or the steepest slope. The upslope area is the number of upstream cells that drain into a certain cell. So you can see here, this is just a pictorial example, and you can see first, you can see here this is nothing but the elevation values, which is in a gridded format like a digital elevation model data. And in the right hand side you can find these are nothing but the directions, so each value represents a direction. So you could see 1 is east, 4 is south, 64 is north, and 16 is west, and 8 is southwest. Likewise, this is just the directions, and based on the direction and the elevation value, if it is take this as an example, this square, you can see here from 78 where the water will be flowing, it will be flowing to 67. So that is, you can see 78 is to from here, it will be flowing to here, 78 to 67. You can check the value of the direction. From here it will be flowing here like this. And after that you can see from 56 where the water will be flowing. So from 56 still you can see from here, this is 56, it is flowing to the 4. 4 is nothing but the direction south, because in south you can see there is a elevation of 37. From 56 it will be coming down to 37. Like this the algorithm works. Now let us move on to QGIS. After that we are going to save it to a particular location, and I am going to name it as watershed or basin, whatever. So I am going to give a name watershed, save it, and let us run it. Now the process has been completed. Let us close it and extend the tool. Now you can see we have successfully created the watershed. If I just add the channel to the top, you can have a good look at it. Right? Now what we are going to do is we are going to convert this watershed from raster to vector. So move on to the option raster and come down to conversion. From here you can see raster to vector, polygonize. Our input file will be watershed, and we are going to convert to as a shapefile. So let us save it to a particular location, and I am going to give the name watershed once again. Save, click run. Now the process has been completed. Let me remove this, and you can see you have successfully converted the raster to vector file format. You can also clip the channels. You can see a lot of channels are available here. You can clip it using the vector. In a geoprocessing tool you can find clip, and the input layer will be channel, and the overlay layer will be watershed. So let us save it to a file, channel watershed. Click on save and let us run it. Now the process has been completed. Let us close it, and let me bring on this channel watershed to the top, and let us remove the other files. Now let me change the color for it. Okay, now click OK, and if you want to change the symbology you can do so. So just move on to the top option, and you can find here wavery line. Once again we are going to change the color, apply, OK. Now you can see successfully generated the watershed using QGIS. In order to make it more visually appealing, so let us first remove the unwanted files, for example this layer. Now let us allow this watershed boundary. Simple fill, simple line, I am going to use simple line, and let me click apply and click OK once again. Now you can see here, let us enable this DEM and make a duplicate out of it, and here we are going to go on to the symbology, and I am going to use hillshade. Click on apply, click OK. Now you can see how it is looking like. Now here once again go on to properties and let us select single band pseudo color, and I am going to pick this color ramp which is there in default. Let me click apply and click OK. Before that, okay, click OK. Now after that we are going to add this copy hillshade which we have done, and go on to the properties, and here you can see transparency. We are going to reduce the transparency, so I am going to reduce the transparency to 47, and you can see the difference. Now you can see how it is looking like. You can also add some effects to the watershed boundary. Now you could see the simple line. So under that you can find the draw effects, enable it, and you can click on the star. You can use many functions are available. I am going to use the inner shadow. Let us see how it looks like. You can see here, and let us try with the drop shadow also. Click on OK, click apply. Now you can see how it is. So likewise you can set effects and you can work on it. So I'm going to choose inner shadow once again, click on OK, click apply. Now if you want you can also add the base map to it. So I'm going to add the National Geographic map as the base map, and now let us bring it and drop it down below. And here you can reduce the transparency for the DEM fill. So I'm going to reduce it to somewhere between 72, or let us see, you can reduce it like this. Actually you can see some changes. You can see some water bodies effects is coming up here. Like this you can do. If you want you can also add the stream orders. So go on to the channel watershed, and here you can find the option properties. Under that you can choose labels. In labels you can use single labels. So in the values we are going to use the order and click on apply. So you can also find the stream orders from here itself. You can find the stream orders. If you want you can reduce the size of the fonts. So let me reduce it to 7 and click on apply, click OK. Now you could see the stream orders also. Quite easily you can find it out. So like this you can prepare the delineate the watershed and prepare the maps using this. So if you have any other doubts in this, please to ask in the comment section. I will be answering to your questions. Thanks for watching. uh, Goodbye everyone.